In this lesson you will learn about function notation. And the best way to understand function notation is to compare it to something we know. So if you're asked to find the value of y when x equals 2, and you're given y equals 3x plus 1, you would take the value of 2 and substitute it in for x, so that we get y is equal to 6 plus 1, y is equal to 7. So an x value of 2 and a y value of 7 means that we would have a point of 2, 7. We always write the x first and the y second. Over here on the right side of the screen, if we're asked to find f of 2 and we're given f of x equals 3x plus 1, we're doing the same thing, but the notation is just a little bit different. 2 is in place of this x, so 2 gets replaced with this x, so that we have f of 2 is equal to 3 times 2 plus 1, f of 2 is equal to 6 plus 1, and we get the same answer. The setup, or the notation rather, is just a little different, and we can still express this as a point as 2, 7. In this next example, now we're asked to find the value of x when y equals 2. So now I would take 2 and substitute it in for y and solve for x. And my first step would be to subtract 1 from both sides so that I get 1 is equal to 3x. And then when I divide both sides by 3, I get x is equal to 1/3. So as a point, I always write the x first, 1/3, comma, 2. So using function notation, when you're asked to find x when f of x equals 2, 2 gets replaced with the entire f of x, not just the x, so that I have 2 equals 3x plus 1, and the rest is exactly the same. And we get x equals 1/3, and to write this as a point, it would be 1/3, 2. So now let's look at function form and function notation. If you have an equation in standard form, you have x and y on the same side of the equation, but to change it so that it's in function form or slope-intercept form, you want to solve for y. And to solve for y, you always start by either adding or subtracting the x term over to the other side of the equation, and we have negative 4y equals, I write the x term first, the 12 is positive, so we add 12, and then the last step is to divide by negative 4. All of the terms get divided by negative 4, and we have y equals, the negatives cancel, and we have 3/4 x, and then 12 over negative 4 is negative 3. So function form is y equals 3/4 x minus 3, but then function notation is f of x equals 3/4 x minus 3. The second example, again, we want to solve for y, and we start by moving the x term over to the opposite side of the equation by either adding or subtracting. Keep the sign of the 4 negative, so we have negative 4y equals, write the x term first, the constant second, divide by y's coefficient, so that we have y equals negative 2 over negative 4 reduces to 1/2 x, and then negative 8 divided by negative 4 is positive 2, so we add 2. So function notation is y equals 1/2 x plus 2, and then, or function form rather, is y equals 1/2 x plus 2, but then function notation is f of x equals 1/2 x plus 2. And the next example, 2x plus 6y equals -3. I start by subtracting 2x from both sides, and I have 6y equals -2x minus 3. I divide everything by y's coefficient, so everything gets divided by 6, and I have y equals -2 over 6 reduces to -1/3, and -3 over 6 reduces to -1/2. So function form is y equals -1/3 x minus 1/2, and function notation is f of x is -1/3 x minus 1/2. For this next example, to solve for y, this one is very simple. All we have to do is divide by 2. So when we divide by 2, function form is y equals 2, and function notation is f of x equals 2. The next one, we start by adding 6 to both sides. We're just solving for y. If you don't have an x term, it's usually a little bit shorter. -8 plus 6 is -2, and then to get y by itself, we divide by y's coefficient of -1, and we get y equals 2. So actually the same answer. Function form is y equals 2. Function notation is f of x equals 2. And this last example, we don't have a y to solve for. I can solve for x though, and if I solve for x, I get x equals -2. This doesn't help me in writing it in function form because function form must be in the form y equals. So therefore I can't write it in function form. It's not a function. So if I can't write it in function form, then I can't write it in function notation. So the directions are for questions 1 through 3 is to find f of -2. And when we're finding f of -2, -2 gets replaced with the x in parentheses and then the x in the problem. So it's 4 times -2 minus 5. And if we take 4 times -2, we get -8 and then minus 5. -8 minus 5 is -13. So our final answer is f of -2 equals -13. For number 2, we're still asked to find f of -2. So -2 gets replaced with the x in parentheses and then the x in the problem. So 3 over 2 times -2 and then minus 1. So with the order of operations, we have to multiply first. So when we multiply 3 over 2 times -2 over 1, the 2's cancel, but I'm left with a -1. So that f of -2 equals -3 minus 1, which is -4. So my final answer is f of -2 equals -4. For number 3, when we find f of -2, we place the -2 inside the parentheses and then in place of x in the problem. But there's nowhere to replace x with a -2. So our answer is just -1. For number 4, If f of x equals negative 10x plus 4, we want to find x if f of x is negative 16. So on this problem, the negative 16, since it represents f of x, it replaces this entire quantity with a negative 16, not just the x. So that I have negative 16 equals negative 10x plus 4. And now we just use algebra to solve for x. So I subtract 4, and I get negative 20 equals negative 10x. I divide by negative 10, so that x is equal to 2. For questions 5 and 6, we're asked to graph each function. And for number 5, we have f of x equals negative 3 over 2x plus 4. So remember, f of x is the same as y equals negative 3 over 2x plus 4. And this equation is in function form or slope-intercept form. And I know that the slope is equal to negative 3 over 2. So we always move to the right with the denominator, and the top number, depending on if it's positive or negative, tells us to go up or down. Since it's negative, we go down. So we'll be moving down 3, right 2, and this number 4 here is our y-intercept. So we have a y-intercept of 0, 4. So if we're graphing the function, we start at the point 0, 4, and we move down 3, right 2, and you could move as many times as your graph fits. 1, 2, 3, 1, 2. Connect the points, and there's your line. Place arrows at the end and make sure to extend it past all of the points that you graphed. For number 6, f of x equals 1/2, which is the same as y equals 1/2. And this is in slope-intercept form because we have it in the form y equals, but without an x, we could write this as 0x plus 1/2, but you don't have to. But if we did, it shows that we have a slope of 0 and a y-intercept of 0, 1/2. So if I plot the point 0, 1/2, and notice that I have a slope of 0, horizontal lines have slopes of 0. So my line is just a horizontal line passing through the y-axis at positive 1/2. The next group of problems, 7 through 9, we want to write the equation of the graph in function notation. So if we compare this to slope-intercept form, mx plus b, and we find our b first, b is the point 0, negative 3. So our b is equal to negative 3. And then our m is the slope. So I have the point 0, negative 3, and I also have this point right here, 1, 1. So if I go up 3 and then right 1, my slope is equal to 3 over 1. My slope is positive because my line goes up from left to right, and you can write the slope as 3 over 1, or just 3 is fine. Substitute the numbers in, and we have y equals 3x minus 3, but the question asks us to write it in function notation, so it's f of x equals 3x minus 3. So for number 8, I'll write the slope-intercept form of a line, and I start by finding b first. B is the point where the line crosses the y-axis, which is at 2, so b equals 2. Next I find m. M is the slope, and since my line goes down from left to right, I know that my slope will be negative. So I want to identify another point, which I see another point right here, and I'm going down 2 and then right or over 3. So it's 2 over 3, but negative. I take m and b and substitute it in to the slope-intercept form of a line. And then I have to write this in function notation. So f of x equals negative 2/3 x plus 2. For number 9, this is our line right here. And if we follow y equals mx plus b, I'll start once again by finding b. B is the y-intercept, and it crosses the y-axis at 4. So b is equal to 4. Now our m is very simple to find because our line is horizontal, and all horizontal lines have a slope of 0. So if I substitute these two values into the slope-intercept form of a line, we have 0x, which is just 0, or we can just write y equals 4. But then to write this in function notation, it's f of x equals 4. So for number 10, we want to write the equation of the graph in function notation if f of 3 equals negative 4 and f of negative 1 equals 2. So let's keep in mind that f of 3 equals negative 4 is the same as having the point 3, negative 4. And f of negative 1 equals 2 is the same as having the point negative 1, 2. So we could graph this, that's one option. But I'm going to do this by looking at y equals mx plus b and finding m and b. And on this one, since I'm given 2 points, I'm going to start with m. M is the slope, and the formula is y2 minus y1, and we divide it by x2 minus x1. So I'll label 3 x1, negative 4 y1, negative 1 x2, and 2 as y2. So I plug the numbers in, 2 minus negative 4 over negative 1 minus 3. 2 minus negative 4 is positive 6. Negative 1 minus 3 is negative 4. This fraction reduces by 2 to give us a slope of negative 3 over 2. So we have a slope of negative 3 over 2, and we're trying to find b. So what I'm going to do is I'm just going to pick one of the points, either 3, negative 4 or negative 1, 2. I'll just use the first one, but it doesn't matter which point you pick. And I'm going to make x 3, y negative 4, and substitute the values into mx plus b and solve for b. So negative 4 gets plugged in for y, m, negative 3 over 2, and then times x, so times 3, plus b. And I start by multiplying these two fractions to get negative 4 equals negative 9 over 2 plus b. And to finish solving for b, I add 9 over 2 to both sides, and I get b is equal to negative 4 plus 9 over 2. So let's do this work. My next step is to add 9 over 2 to both sides. And on the side here, if I take negative 4 over 1 plus 9 over 2, these cancel. I have a common denominator of 2. So I would multiply this fraction by 2. And I have negative 8 over 2 plus 9 over 2, which is 1 over 2. So my b is equal to 1 over 2. And all of this was for the purpose of finding mx plus b. M, again, is negative 3 over 2. X plus 1/2. And then we want to write this in function notation. So f of x is negative 3 over 2x plus 1/2.